Right, section 3.2. So yesterday we did this. We had two lines, and they were not necessarily parallel, were they? So we had two lines and a what? What was that thing that crosses those two lines? What? A transversal. Very good. So we had two lines cut by transversal. Today we're going to get a little bit more specific. Instead of just saying any old two lines, we're going to talk about two, what kind of lines do you think? Parallel lines, right, because that's what we've been talking about, is parallels. So let's draw two parallel lines. We'll make that as simple as we can. We'll just make them go nice and straight across like this. And let's do that transversal in red. That's kind of what we did yesterday, so let's kind of stick with that same color theme here. Alright, so there's our transversal. And let's put some, just looking at this picture, are those two lines parallel? No. Not just looking at it, you got to say that they're parallel, right? So you could either label them, call this like line L, line M, and say that line L is parallel to line M, or what's an easy way just to look at it and see? Put a little arrow, right? Put an arrow here and an arrow right there. So that means that those two lines are parallel. That's very important to know that they're parallel. Don't make any assumptions about it. Make sure that you know that they are parallel. And let's put the numbers in here like we did yesterday. Now, this looks very, very close to what we did yesterday with one really big exception. What's the big exception? The lines are parallel this time, okay? The lines are parallel. Yesterday, the lines were not parallel. All we did was learn the names of the relationships, okay? But now we're actually going to learn something about the measures of the angles, okay? What angle is equal to another angle, that kind of thing. So if we have parallel lines, here's the first thing. Remember how we talked about corresponding angles yesterday? There's something about the corresponding angles that are exactly, there's something in common with the corresponding angles. Just make a wild guess. What do you think? Look at angle 1 and angle 5. They're corresponding angles, aren't they? What do you think might be true about angle 1 and angle 5? Just look at the angles. Yeah, they're probably equal. I like how she said that. She said they're probably equal, right? And they are equal, all right? And we know that they're equal because we have a thing called a postulate. In geometry, you'll see all kinds of rules and things like that. You've heard of the Pythagorean what? What do we call that? Theorem, right? Well, postulate is kind of like a theorem. It's kind of like a rule that we learn, but it's accepted without proof. We don't have to prove a postulate. It's just something that they tell us, and we just accept it as fact. All right? So you might want to jot that down somewhere. The difference between a postulate and a theorem is a postulate, they just tell us that this is true, and we just accept it. All right? Now, if we wanted to, we could get a protractor and measure it, and we would see, as long as these two lines are parallel to each other, we would see that the corresponding angles are equal to each other. So that is a postulate. So let's write it down. I'll just shorthand it. Let's do this. Let's not just start off with that. What's the if part? If what is true about the two lines? Right, if the two lines are parallel. So watch, if two lines are parallel, I'll just put the symbol for parallel. All right. So if you have two lines that are parallel, if you have two parallel lines, then, all right, that's a big if. All right, the lines have to be parallel for this to be true. This is not true yesterday. Remember the two lines? They were not parallel. So the corresponding angles didn't have this relationship yesterday. They do today because we're just talking specifically about parallel lines. So if the two lines are parallel, then the corresponding angles, and what did you say they look like they are? Look at 1 and 5. Look at 3 and 7, 2 and 6, 4 and 8. They're equal to each other, right? Then the corresponding angles are equal. Or in geometry, a lot of times we say congruent. I've shown you that symbol before, haven't I, for congruent? Yeah. So if the two lines are parallel, that's a big if. They got to be parallel to each other. Then all the corresponding angles are equal to each other. All right? That's what this postulate says. We don't have to prove it. It's just whoever came up with this decided that was true. They didn't just decide it was true. I mean, it actually is true. If I took any two lines and I cut it with another line, those angles, those corresponding angles that are formed will always be parallel or equal to each other. So angle 1 is going to equal angle 5 now, isn't it? All right. Now remember before, yesterday we just said angle 1 and 5 were corresponding angles, and that's the only thing that we said yesterday. But today, now we can say that they're corresponding, but we can also say, if we have parallel lines, what's true about 1 and 5? They're equal to each other. Exactly right. All right, so that's kind of nice. Look at With that said, we could look at a lot of other things too. Look at this. 1's also equal to 4, isn't it? Give me a reason why 1 and 4 would be equal to each other.
Because they're like
They're vertical angles, okay? They're vertical angles, right? And vertical angles are equal. Destiny? Why don't you write some of this down? That'll help you. So watch. 1 and 4 are vertical angles. So 1 is equal to 4, isn't it? You see that? What must be true about 4 and 5 then? Okay, why do you think 4 and 5? Because they both have one arc, right? Because 1 and 5 is equal, 1 and 4 is equal, so guess what? 4 and 5 is going to be equal as well. And what's the relationship between 4 and 5? They're alternate interior angles. Very good. So what do you think we can say about alternate interior angles? That they're equal to each other, okay? That all came from what? That all came from two things. First of all, knowing that the corresponding angles are equal, and secondly, knowing that the vertical angles are equal. All right. So we don't call that next one, we don't call that a postulate, we call it a theorem, because we actually kind of came up with that on our own, didn't we? All right. The postulate they had to tell you. All right. We wouldn't have really known unless they told us. All right, that 1 and 5 are equal. But we do know 1 and 4 are equal to each other because we already know vertical angles are always equal. And then we can say 4 and 5 are equal because of all those angles that are marked equal like that. Okay, so let's do this though. Before I move on to the alternate interior, let's list all the things that are equal because of corresponding angles. All right. So 1 and 5 must be equal to each other. You agree with that? I'll tell you what. Let's keep that little arc right there. So 1 and 5 are equal to each other. Let's just jot it down. So angle 1. Now look what I can do now. I can say it's equal to angle 5. Yesterday I didn't do that, did I? Put a little comma in between there because all I was doing was saying 1 and 5 are corresponding angles. All right, now I can say that they're equal to each other. They're equal to each other because the lines are parallel. All right, so 1 and 5 are equal. I'll tell you what, 1 and 4 is equal, but what is a corresponding angle with 4? 4 and 8. And they should be equal to each other too, because look, 5 is equal to 8, isn't it? So 4 and 8 must be equal to each other. Do you agree? All right, so let's write that down. So angle 4 equals angle 8. Let's go to some of the other angles. Let's go angle 2. What do you think angle 2 is equal to? Okay, it is 3, but by corresponding angles, though. I should have been more specific. Because of corresponding angles, angle 2 is going to equal to what? Angle 6. That's right. So what do I put here? Do I just put one arc here? Put 2, because angle 1 is not necessarily equal to angle 2, is it? So if they're different angles, I put 2 arcs for 2. And I can put 2 arcs for 6, can't I? All right? Does that make sense? So let's write that down. So I can write down angle 2 is equal to angle 6. You could always put congruent in here, but sometimes I'm lazy and I just put equal. What else is equal because of corresponding angles? 3 and 7. And look, 2 and 3 are equal, right? So I should be able to put a little arc here. 6 and 7 are equal, so I should put a couple arcs right there. Do you see that? So that tells me that 3 and 7 must be equal as well. But I also know that because I know that the corresponding angles are equal. So we got 2 and 6, and now we can say 3 and 7. So angle 3 is equal to angle 7. So you know those 4 things because of corresponding angles. All right? Because you know that the corresponding angles are now equal to each other. They're congruent to each other. That must mean all the corresponding angles are equal. So I just listed them. That's all I did right there. Does that make sense? It's not so hard, is it? Let's look at some other things. And we kind of... tell you what, you've got it written down. I'm just going to get rid of it right here just to give myself some room because I want to keep that picture right where it is. All right, so look at all this stuff that's equal. 1 and 4, 5 and 8 are all equal to each other. 2 and 3, 6 and 7, they're all equal to each other. Everybody see that? But let's take a look at this name. Look at the alternate interior angles. This is actually a theorem. It's not a postulate. Remember, a postulate is just accepted with no proof at all. It's just accepted as fact. A theorem you kind of have to prove. And we did that. We basically already did that. We said 1 and 5 are equal because of corresponding angles. That was a postulate. But we also said 1 and 4 are equal. So look, 1 and 5 had one arc. 1 and 4 have one arc. So guess what must be true about 4 and 5? They got to be equal as well, right? Look at the other alternate interior angles. 3 and 6, are they equal to each other? Yeah, absolutely. 3 and 6 are equal. So what do I know about alternate interior angles? Yeah, tell you what, let's do this. Let's write what we did before. So my theorem says this. If you have two parallel lines, that's very important that you start with that. If you have two parallel lines, then this is called an if-then statement, all right? Because this part is if, this is then. If you have two parallel lines, then what must be true according to this theorem? The what? The alternate, well, we already did corresponding. This is the new one. This is alternate interior angles must be what? Equal or congruent. Everybody see that? So far, all the corresponding angles are equal, and guess what? All the alternate interior angles are equal to each other. So let's list those. Angle what? 3. What's alternate interior with angle 3? 6. So angle 3 and 6 are equal to each other. What's your other pair of alternate interior angles? 5 and 4, 4 and 5 is what I was looking for. Not 2 and 6. 2 is an exterior angle. They're corresponding to each other. Okay, alternate interior angles. 3 and 6, and then 4 and 5. All right, so those are my alternate interior angles. Does that make sense? What's another one that we had? Alternate what? Exterior angles. Let's just see if the alternate exterior angles are equal to each other in this situation. Look at 1. 1 and what? 8. They both have one arc on them, don't they? So guess what's true about 1 and 8? They're equal to each other. Look at, what's the other one? 2 and 7. They have 2 arcs on both of those, right? So they're equal to each other. So guess what I can say? I can say, here's another theorem. This is a second theorem. If two lines are parallel, or if you have two parallel lines, forgot my L right there. Looks like 3. But if two parallel lines are cut by a transversal, okay, but if you have two parallel lines cut by a transversal, then what else is true? The alternate what? Oops, I put interior. The alternate exterior angles are also equal to each other or congruent. All right, I got two parallel lines cut by transversal, then the alternate exterior angles. Let's list them. We already did it just a second ago. Angle 1 is equal to angle 8, and what else? Angle 2 is equal to angle 7. Good. And this is very, very important because you have a feeling what they're going to do, don't you? They're going to give you a value for one of these angles, and they're going to ask to find all the other ones. And we'll do a quick little example in a second. But I got one more thing to do. What's the fourth thing? We did corresponding. We did alternate interior. We did alternate exterior. That's 3. What's the fourth one that we did yesterday? Consecutive what? Interior angles. Which ones are consecutive interior angles? Okay, 4 and 6. Remember, it's like the same side interior. Remember that? So the ones that are on the same side. So 4 and 6 are consecutive interior, and what else? 3 and 5. Good. 3 and 5 are okay. Well, I wouldn't say they're opposites. They're kind of like right. Oh, I see what you're saying as far as the value of them. Right. Look at 4 and 6. Are 4 and 6 equal to each other? There's no way. Look at 4. What kind of an angle is angle 4? It's obtuse. What kind of an angle is angle 6? It's acute. Is there any way an obtuse could equal an acute? There's no way in the world. Because acute means less than 90. Obtuse means greater than 90. Can you get a number that's both less than and greater than? Of course not. No. So 4 and 6 are not equal to each other. But watch this. Let's do a little mini proof here. What do I know about 3 and 4? If I took angle 3 and added it to angle 4, what would I get? I get 180, wouldn't I? Everybody see that? Why? Because it's supplementary, because they form a straight line. Good. All right, linear pair. Remember that phrase? All right, so so are we all in agreement that angle 3 plus angle 4 is 180 degrees? All right. Look at 3 and 6. What's true about 3 and 6? They're equal to each other, right? So angle 3 is equal to angle 6. Now follow me. Instead of saying 3 plus 4 is 180, guess what we could say? That's right. So let's replace this. Let's replace that 3 with a what? With a 6. So now I could say angle 6 plus angle 4 is equal to what? 180. Look at 6 and 4. What are they? They're consecutive interior angles. So what then can I say, do you think, about consecutive interior angles? That they add up to what? 180. Okay, they are, give me a good word. You said it already. If they add up, say it, Javi. Supplementary, right. They're supplementary to each other, okay, because they add up to 180. So 4 and 6 are not equal to each other. They're what? Give me the word, one word. Supplementary. What about 3 and 5? They're supplementary as well because they're consecutive interior angles. Let's write a little theorem down for this. So how do we start this off? If what? If two lines are parallel, or if two parallel lines, however you want to say it, doesn't really matter. Okay? Technically, it's if two parallel lines are cut by transversal. I just left out the cut by transversal thing, okay? So if you have two parallel lines, then which ones are we talking about now? The what? Consecutive interior angles are what? Not equal, but supplementary. Okay, very good. I'll just put sup. Is that all right? What's up? All right, supplementary. That's what we should say now. Yo, what's supplementary? All right. All right, so if two lines are parallel to each other, then the consecutive angles are supplementary to each other. All right, so 4 and 6 add up to 180. 3 and 5 add up to 180. Now, if you look at this, look at all the angles that are equal, 1, 4, 5, and 8. What kind of angles are 1, 4, 5, and 8? No, not vertical. What are they? What type of angle is angle 1? They're obtuse, aren't they? Look at angle 1. It's obtuse. Look at angle 4. It's obtuse, isn't it? You see that? So, even if you didn't know all these names, what could you say in this situation about all the obtuse angles? So, I'll put this. Right. All the obtuse angles are equal to each other, right? And you could also say what? All the acute angles are equal to each other. Would you agree with that? Because look at it. 2 is acute, so is 3, so is 6, so is 7. And they're all equal to each other. It's kind of an easy way to look at it, isn't it? All right, so if you have two parallel lines, again, this only works. I've said this like 5 times a day. This only works if you have two parallel lines cut by transversal. It doesn't work with just any old two lines that are slanted, okay? They have to be parallel lines, but if they are parallel lines, then all the acute angles are equal, all the obtuse angles are equal. Does that make any sense? All right, let's do a couple little examples here. Let me see if they give a good one. Yeah, I'll tell you what, I'll do a super easy one first, then we'll work our way up to one that may be just a little bit tougher. Now, they don't all have to look like they're horizontal like this, all right? So don't think that always has to be true. But, oops, sorry. They could go like this. I'm going to copy and paste it to make sure it's parallel. And let's put a transversal in here. Make it red again. And we'll just say it's like that. I'm just going to make up something. This is my own made-up example. And by the way, I put 2 arrows there, so what's true about those 2 lines? They're parallel. Now, before putting them there, it might have looked like they're parallel, but we couldn't say for sure, could we? All right, so by putting the arrows there, that means they're parallel. What if I said that this angle right here was 50 degrees? You should be able to find every single one of those other angles. So let's think about it. I'm not going to number them. I'll just point. What about this angle right here? What's that going to be? It's going to be 50. All right? Because remember, all the what? All the acute angles are equal and all the obtuse angles are equal. But let's give reasons though. Why are these two equal to each other? Because they are vertical angles. What about this angle right here? This is 40? It's 50 as well. Why is it 50? Because what? Yeah, all the acutes are equal. But let's give one of the theorems or postulates that we did. You could say it's because of these two. What if I use this reason? What about these two? These two are equal. Why are these two equal? Because they are alternate interior angles. Or you could have used another reason and said this one right and this one right here are equal. And what would your reason for that be? Corresponding, right? So it all depends on which one. But either way, they're all equal. What about this one down here? That's got to be 50. So how easy that is? It's not hard, is it? Okay, what about this one? We got to do a little math though. Okay, take it away from 180. That's right. So what's that give you? 130. Good. All right. Do you see that? Because it formed a straight line, didn't it? All right, so that has to be 180. Or this one and this one formed a straight line. Would you agree? It works either way. All right, so that's 130. What about the rest of them? They're all 130. See how easy that is? Simple, isn't it? And there you go. So you've listed. All I gave you was one angle, and you found all the rest of them. It's not hard at all, is it? Nope, I don't think so. Let's do another one. Let's make this one a little bit tougher. You know how they give missing things and they don't say necessarily exactly what angle is? Sometimes they'll say it's like 2x plus 3 or x minus 5 or something like that. That's what we're going to do right now, okay? And let me do the one straight from the book because... Let me copy it. Because their numbers will probably come out nice. If I just made stuff up, they might come out as fractions and look real ugly. So let's make my transversal go about right here. Oh, by the way, oh yeah, I did say they're parallel. Yeah, I'm going to give you a worksheet. What time's this class over?
In 30 minutes.
30 minutes?
3 minutes.
3 minutes, okay. Let's do this real quick. I'm just going to put the value in here, 2x minus 17. So this one right here is 2x minus 17, that angle right there. And angle 1, which is 85. This is 85 degrees right there. Okay? Let's take a look and see if we can see some kind of relationship between this and this. Everybody looking? Come on. Hey, don't quit on me, Net. Look at this and this. Are they equal to each other?
No.
Now, because this is acute and this is what? Obtuse. What's true about an acute angle? Well, look, I could do this too, couldn't I? This is 85. What's true about these two? They're supplementary, aren't they? So how do I set my math up? I don't set them equal. What do I do? I add them. Well, I don't plug them in yet. I got to find x. So I add them, right? I add them together, and I set them equal to what? 180. Now, we're running out of time. We just ran out of time. And then you can solve for x. Right, and that's all you do. All right? Yeah. Well, I would take negative 17 and 85, add them together, then subtract that from both sides divided by 2. It's just algebra. Let me give you a worksheet. Don't leave yet.